Single rule to find transform is, I'm telling you, Z transform. This is basic formula. See, we use this symbol and for which we are finding like if we need to find for xn of the sequence, then we'll take summation n is equal to 0 to up to infinity xn, and they'll give you that sequence, okay, xn into z to the power minus n. Okay, if sequence xn is equal to n, okay, then you'll use here n. I mean, this is nth term of sequence we are using. Are you getting me? Leo, you can type also, okay? Yes. So whatever you need to transform by using that transformation or that transform, just like you have anything here, obviously you will write here inside the summation and will multiply with z to the power minus n. Got it? And just simplify and that will be the answer. Okay? And like if in 9th, 10th and 11th question, you need to find like many transform of many terms. Like for example, you need to find for n square. So obviously you will put here n is equal to 0 to infinity n square and just z to the power minus n. Got it? If you need to find n, then obviously we'll take here n. If you need to find just, we have done a into b to the power n, then obviously we will take here a into b to the power n. Now you got, how can we find z transform? You got it now? All right. So let's see the next. Okay, I'm checking. Because here questions are incomplete. I'm checking the complete question. One second. One second, okay? I'm checking. See, in this 13th question, you will understand well. We have sequence, they have mentioned you xn is equal to a to the power n over factorial n, which we have inside the summation. Are you getting me? 13th question. Okay. And that is why
Yes,
we
sir.
are using this. And we'll take z to the power minus n in denominator and can write together with as summation n is equal to 0 to infinity 1 upon factorial n and a over z to the power n. And we can expand it. Are you getting this? 13th question. You got?
Yes, ma'am. Got it.
So now let's see the next z transform of ft, where ft is given by. First, we have ft is equal to t. Next is ft is equal to e to the power minus t. And third one is e to the power at. And we have further, okay? So, see, We need to find Z form
Can
of
we do
Z
this question
transform
in
of
Mapur now?
ft. So, we have done formula. If we find Z transform of ft, we have formula summation n is equal to 0 to infinity and f nt into Z to the power minus n. Remember this?
And can we do this question in whiteboard?
Okay. Just few seconds. Page number 22. I'm just opening my phone to see the question. So, question is, I'm telling you the first part and also will tell you fourth one, okay? Rest of you can try yourself, okay? Alright. First question, we have ft is equal to t. They have given to us. Z transform of ft is zft is equal to summation n is equal to 0 to infinity f n capital T into Z to the power minus n. Since we have T only, okay, ft is equal to T. So let us find Z transform of T. It will be summation n is equal to 0 to infinity. And instead of small t, we use this nt, okay? So similarly, we will use here into Z to the power minus n. Okay. T is constant because T is constant. So take it outside and can take it. N is equal to 0 to infinity and n into Z to the power minus n. Or we can write T is summation n is equal to 0 to infinity and upon z to the power n. So now let us find the expansion for this. Okay. So we will have t inside, we have 1 upon z plus 2 upon z square plus 3 upon, sorry, yes, first term, yes, we have 0, sorry, because we'll start from 0. So n is equal to 0. Obviously, we will have first term 0. And next term we have, yes, 1 upon z you got. And 2 upon z square, 3 upon z cube plus up to. So just few seconds, I'm just checking. You have book of this, which you have page number 9 and problem number 4. You have book of this, or they are talking about this PDF. You have book,
I'm just PDF on the. There's no book.
page number.
9 is there.
Yep. Yes, we have here expansion of this. So in each term, we have 1 upon z common here. So further we have 1 plus 2 upon z plus 3 upon z square plus up to 4. Or we can write 1 plus 2 into 1 upon z plus 3 into 1 upon z square plus up to so on. And which is equal to, we take this, like if we find binomial expansion of this, even we will use this directly further, because binomial expansion of 1 minus 1 upon z to the power minus 2 is same as this. Okay, is same as this expansion. 1 plus 2 over z plus 3 over z square and plus 2, so on. So whenever we have this expansion, we write directly this. Okay, that is why we have taken this. So we can write this expansion is equal to 1 minus 1 upon z to the power minus 2, or t over z, z minus 1 over z to the power minus 2. Or we can write z square over z minus 1. Okay, so we can cancel one z. So we have dz upon z minus 1 whole square. Got it now? So z transform of t is equal to this. Okay. So next, let us do fourth part. Rest of the second, third, you can try yourself. Okay. Now let us do fourth part, and fifth and sixth you can do also. So given that ft is equal to sine omega t. So now let us use formula. Yes. Just few seconds. Okay. Then z transform of sine and theta. In a state of n theta, we have this. Okay. So we will use according. Is equal to z into sine theta over z square minus 2z cos theta plus 1. If absolute value of z is greater than 1. So now let us try. So here ft is equal to sine. We have already written. Yes, yes. So, that ft is equal to z sine omega t. See, if we have like we can write this z sine omega nt also. Remember, because we write like if we have here small t, then we use this capital NT. But in transform, we don't use here n, okay? That is why we are using omega t only. So we have z into sine omega t over z square minus 2z cos omega t plus 1. You got? Yes. Rest of questions you can try yourself. Okay. See, let's next 125 page number shifting theorem. Okay, let us do. Let us do. See, shifting theorem one. If z of t is equal to fz, then z of means z transform of e to the power minus at into ft will be f z into e to the power at. Like we will use this. Here we are doing
Can
2, but
we do
further we
this
will
in
use
whiteboard,
these theorem
ma'am?
into questions. Yes, tell.
Ma'am, can we do this theorem in whiteboard?
See, I'm telling you what it here. Okay, then you will not understand. Then I'll explain you on whiteboard because this is so simple. You will see.
Okay, ma'am.
Okay. See here, fz we are taking as zft. See, in first row. Further, we will use this theorem as a formula in questions. Okay. So let us see the proof here. Given they have given to us fz is equal to zft. Got it? The first condition they have given to us. And as you know, z transform of ft is we write summation n is equal to 0 to up to infinity f n into capital T instead of small t. Remember? And into z to the power minus n. You got now?
Yes, ma'am.
Yes. Now we are using together with e to the power minus at with this, with ft. First line of proof is of zft. And in next, we are taking together with e to the power minus at with ft. Okay. So obviously, as we have discussed in transform, whatever we have inside of C, together with z, we write inside the summation. You remember now? See this line?
Yes, ma'am.
Yeah. So that is why, because we have here z, like z transform e to the power minus 80 into ft. That is why we have inside the summation n is equal to 0 to infinity. We have same thing here. See, e to the power minus a and t, because in a state of t, small t we use n into capital T. In a state of ft, we have here f and capital T into z to the power minus n, according to formula, as we have done. Now you remember? Now this line is clear to you? This one? Top line? Yes. And because we have negative power of both, like see, we have e to the power minus a and t, and also have z to the power minus n. So we can take them together, z into e to the power a into capital T and whole power minus n. You got this? This line? Just combined e to the power at and z, because both having power minus n together. Got it? Yes. And here, which is equal to z transform of ft, because in a state of z, we are using z into e to the power at together with. Okay, which is equal to z transform of ft, but in a state of z, we are using z into e to the power at. Now you got? So that is why this is transform of z into e to the power at. Now you got? Yes, that is why I was saying that this is so simple. You'll understand well, because based on previous formulas. So we can write the z transform of e to the power minus at ft is equal to z transform of ft when we are using z as z into e to the power at, or we can write it fz. Okay. Similarly, we can prove the second one. Okay. Similarly, we can prove the second part. When we have positive power of e to the c, we can, in second part, if zft is equal to fz, then z transform of e to the power at into ft will be equal to fz into e to the power minus at. Because we will take when a whole power minus n, then it will be like minus at. Are you getting me? In last step, when you have whole power here minus n, obviously inside the bracket together with z, you need to write here e to the power minus at. Okay, when you will do the second. Because in statement you have positive power. So obviously when you will take whole power negative, then inside you need to write negative power. So finally you will get this transform as f z into e to the power minus at. Got? Yes. Now let us do this question. Find the z transform of e to the power minus at. As we know the formula, we have done just in theorem. Okay. So in the state of ft, we are taking as a 1. Okay. Because we have only z transform of e to the power minus at. So we'll take here ft as a 1. Okay. So we'll write here z into z of 1, where z tends to z into e to the power at, because we have minus, like having minus power of e, like e to the power, we have minus at. That is why we will get in positive power. Okay. So we have done this z of 1. We have done this already. Is equal to z over z minus 1 already. You got? Because we are doing for e to the power minus 80, obviously we will get in positive. See, that is why we have this. You got this step? You got the top row? Yes. So you have the transform of e to the power minus 80, z into e to the power a capital T over z into e to the power a capital T minus 1. Similarly, you can do this second question. Here now we have ft is equal to t. Okay, so obviously we have done already for t. Then we will use this transform. See, z t is equal to capital T z over z minus 1 whole square. Just we have done. Okay, so we will use accordingly. You can do this question. Okay, similarly, the third one. Only we are using the shifting theorem because we have together e to the power minus either minus 80 or plus 80. So we will use accordingly. Okay. Are you getting me? So you can try these questions. These are simple questions. Okay. So till fourth question you can do easily. Sorry, fifth till fifth you can do easily. See, we have these formulas also as we have done shifting properties and we have two more formulas. Okay, so let us know if zft is equal to fz, then z a to the power n into ft is equal to f z over a. See, we have just done in like some time ago as we have done z transform of a into b to the power n, right? Then we have a into z over like b over z that time. Okay. And here we have a to the power n. So let us do this. Let us understand. See. This, see, we need to find a z transform of a to the power n into n. Okay. See, we have done this formula already also. This one I'm telling you here, okay? Just on white. So first question. Hmm. First question we have. That transform of a to the power n into n. I'm just rechecking this. Why they are using here capital X inside we have Z over there. So let me check it. Just few seconds. Okay. See, we can write this summation by using direct formula. N is equal to 0 to infinity a to the power n into z to the power minus n. Or we can write this summation n is equal to 0 to infinity n into z to the power z over a to the power minus n. Okay. See when because we have done z of n is equal to z over z minus 1 whole square. We have done this some time ago. But here we have, instead of z, we have z over a. Okay. So where we have z only, we will use, instead of z, we will use here z over a. Okay. So we can write this z transform of a to the power n into n is equal to z over z minus 1 whole square when we have z tends to z over e. So let us use everywhere where we have z, z over e. Okay, everywhere. Are you getting me? Just simple. We are using the formula. So let us simplify this. Z over A and Z square, sorry, Z minus A whole square over A square. So we have AZ upon Z minus A whole square. Okay. So this is the transform of A to the power n into A. Got it? Or why we are, see, according to first formula, when we use A to the power n together with ft, that will also equal to f of z over A. Okay? Because everywhere in a seat of z, we have z over A. You got? You got now? On page number 28, we have formula just below the fifth question. Yes. Okay. Similarly, you can do the next question, the second question on next page. And further more questions also. Similarly, you can do. So just try them. Okay. Then next session, we will do the shifting theorem second. Okay. Because you have now lots of questions. So just try them more. And in next session, we will do shifting theorem second and initial value theorem. Yes. Okay.